Alright, welcome to Chapter 10, Core Mechanics. Alright, core mechanics are typically something that the designer gets into or works on that the player itself doesn't really interact with or have a lot of knowledge about it, if that makes any sense. So let's go through this and kind of clarify that a little bit. Alright, the objectives, blah, 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 and blah, 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 blah. Alright, so again, core mechanics consist of algorithms and data that precisely define the rules. So your core mechanics start at your game engine. You know, different game engines are capable of doing different things. One of the things that kind of hurt Star Wars: The Old Republic, they picked the hero engine, and not only did they picked the hero engine, but after that they heavily modified that to the point that it was no longer the hero engine. It was some kind of hybrid weird thing. And then anytime a new designer came in or somebody new came into the project, they had no idea how to work or what the limitations were, because while they may have had experience with the hero engine, they didn't have experience with this modified, hybrid thing that BioWare had created. So if you ever want to read an interesting story, there was a game designer, and I don't know if he quit or got fired from BioWare. A few months or something before the release of Star Wars: The Old Republic, which again was a huge MMO at launch. I mean, $150 million to develop. Anyway, he goes on and says what's going on inside the company and how they're scrambling and they're pulling all the resources in, and there are hundreds of people working on this trying to get it out, because it's such a mess and all the different issues that they're having with it. But so interesting story, but I digress. So the big thing is the player doesn't experience core mechanics directly. He experiences them, parts and pieces, but he doesn't go into the game thinking about the core mechanics. He doesn't go into thinking about the limitations of the Crytek engine or something like that. So some examples. The economy in a game. When you think about, and not typically single player games, but let's look at MMOs if you've ever played an online game. Something like World of Warcraft or Star Wars: The Old Republic or EVE Online. The core mechanic says, here's how we're going to introduce money into the economy, and then here's how we're going to remove that money from the economy. You don't want players just, racking up money for no reason and then they have nothing to spend it on. Anytime you give them money, you have to give them something to spend it on. You have to have money sinks in there. Otherwise money becomes worthless. A great example of this is EVE Online. They actually have an economist, with a full master's degree and whatever, working with the game company, to make sure their economy is, working. Because the economy is so player-driven, they need to make sure that they don't do things that interrupt that and crash the economy. So that's where the economist comes in. But for the average player, he comes in, he mines some asteroids, he does a couple missions, earns some money, then he goes and buys a new part for a ship. So he doesn't really interact with the economy as far as designing it and thinking whether it's booming or that kind of stuff. So that would be I guess a good example of a core mechanic. If you ever played Dragon Age, having the extra companions and being able to stop the fight and moving that around, that's a core mechanic. The different conditions, what triggers a victory, what triggers a loss, what triggers the termination of the game. That's all like core mechanics. Is my game a theme park or is it a sandbox? World of Warcraft is a theme park. You go to this quest hub, you grab a bunch of quests, then you move out, you finish the quest, you come back to the quest hub, you turn the quests in, and then you move on to the next quest hub. So that's a theme park. Whereas a sandbox, kind of like EVE Online, you're thrown into the game, there are no quests. You can kind of go do whatever you want. Alright, moving on. So real-time games versus turn-based games. In real-time games, there's all these different mechanics that keep running. If your character just stops in the game world, the game world keeps running. Remember we talked about this game loop for your typical game. All the stuff still happens. The NPCs are still moving. Monsters are still moving, day and night cycles keep rotating, animals keep running around, even though your player's not doing anything. So that's the game loop. Then anytime your player does something, like when he attacks a monster, it triggers an event that then adds into the loop. Okay, monster now activates, monster goes and attacks you, that kind of stuff. So it's not like a Word document where if I don't do anything in the Word, if I just open up the document, type a few letters and stop, like nothing processes, it just waits for me. But games are totally different like that. The game loop is always running in the background. But in a real-time game, things happen real time. When I swing my sword, the damage is applied right away. But in a turn-based game, the damage and stuff isn't applied till the end of my turn. And then they make a note here, when you're designing the game, you should specify, in general how challenges work, but you don't want to get too specific. Wait for the actual implementation process and then let them define what is actually going to happen based on the engine and the resources they have available. Alright, then your book goes on to talk about resources. Now, a resource is a type of object, and an entity is an object. So a pencil, or the category of pencils, pencils are a resource, but this pencil and these three pencils are entities. So the name of the item, or the type, is the resource, and then whatever each individual one is, that would be each individual resource is an entity. Just like for you guys, we're all human, so human is the resource, but boy, girl, or student is the entity that you are. And then the core mechanic kind of drives, how those resources can be traded. There are a lot of things, there are a lot of online games that you play where when you pick something up, it's bind on pickup. So as soon as you touch that object or you claim it, that becomes bound to you and you cannot trade it to another player. And that's also what really ticks people off in games when some magic user who wears cloth rolls for a plate mail armor that he can't even use, and blah. So you get the idea. I digress. Alright, so an entity is an instance of a resource or the state of some element of the game world. Well, what the heck does that mean? So it just means the individual instances of the resource. So if I have 12 pencils, those 12 pencils are entities. But then again, being pencils, the pencil is the resource. Alright, then they go on to give you a couple different examples of entities. A simple entity would be points scored in a basketball game. Compound entity would be the attributes of your character. And if any of you guys are playing Star Wars The Old Republic currently, they actually got rid of a whole bunch of attributes. Each class used to have its own attribute. If you were a healer or a Sith sorcerer, you wanted willpower. And if you were a Jedi Knight, you wanted strength. And if you were like a bounty hunter, you wanted, I think, cunning or aim. They got rid of all that and then just replaced it with one stat called mastery. And again, that goes into the core mechanics. If a game's not fun and there's something restricting fun, you want to change it. So one of the issues that they found were when random loot was being generated, you may find this cool cloth armor for your Sith sorcerer, but it had strength attribute, and you're like, well, I can't use that, and then you just sell it or just get rid of it. So now with only one attribute, if you find something that you like, the stat's going to work because it works for everybody. Alright, and then they follow this up with getting all weird and technical. A unique entity occurs when the game world contains only one entity of a specific type. So a football in a football game is a unique entity. There's only one. But it's a compound entity because it has several attributes: position, velocity, and spin. So besides the exam that covers this chapter, you'll probably never need to know that. So another way of thinking about the mechanics are, they're like the rules about how everything behaves. So it states the relationships between entities. There was a game years ago called Star Wars Galaxies, and you could actually design weapons, and you could actually design a better weapon than somebody else. Every week different resources would spawn, and then they'd be there for a week. Like you could go mine this really cool ore, and then it would be gone. It would be gone forever. So you only had that 1 week to gather as much as you could. And as the years progressed in that game, people that had played it for a long time and had access to all this different unique stuff, and they made the best weapons that did more damage than anybody else's. You could also put scopes on pistols, and you could put stocks on pistols and do all kinds of neat stuff. But I digress. So the mechanics like state the relationship between entities. Hey, this item will go with this item, and then when they connect, they'll become a different item. Alright, and then a global mechanic operates throughout the game, and typically your economy is like a good example of a global mechanic. So then your mechanics have to have some method of identifying events and tracking conditions. What's a win, what's a loss, when does the monster die, that kind of stuff. Alright, then we get into more mumbo jumbo with numeric and symbolic relationships. And a numeric relationship, obviously, between entities is defined in terms of numbers, and then the values of symbolic entities can't be added or manipulated mathematically. And then they kind of give you an example here. So a simple numeric entity would be point scored. I can compare my point score to your point scores, but a compound entity with two attributes like wind would have speed and direction. And then a compound entity containing another compound entity as an attribute, blah blah. You got some dude, you got his stats, and then you got his inventory. All right. Again, now some of the concept of that makes sense, but in the real world, in game design plays, we don't talk about, oh, well, is that a numeric relationship or is that a symbolic relationship? Nobody talks like that. No game designer that I've ever met has ever talked like that. So obviously, a lot of the stuff in these books that they put in there is just to help us make exams, I guess, because you're not going to use that in the real world. Moving on. All right, the eternal economy. All right, a source is a mechanic that defines the way that a resource or entity comes into the game. How do people generate money in the game? So when I hit the go square in Monopoly, I get $200. Or a game like Arcade, every time I log in, I get 5 loyalty coins, and I can use those loyalty coins in the cash shop. So these sources, they can be global mechanics, they can be limited, unlimited. There was a game, and I can't remember the name of it, where there was actually a fixed amount of money in the economy. And people with more money would actually give loans out to other players and stuff. It was kind of neat. I don't know if it's still going on. I think this was something from like 10 years ago, but I digress. All right, so anytime you have stuff coming into the economy, you have to have drains to remove those resources. The last thing you want is players stacking up a whole bunch of resources and then having nothing to do with it, and then it just takes up inventory space, and then they get mad. They feel that, hey, you're creating all this, you're making me do all this stuff because it fills up my inventory. Then you want me to buy inventory things from the cash shop to expand my inventory, and there's nothing to do with this stuff. You also don't want them to devalue the currency. If every player in the game has bajillion dollars, then bajillion dollars doesn't mean anything because they have nothing to spend it on. So why go questing for more money when I got more than I can ever possibly use? So besides adding drains in there, something to take the money out, you can do converters. And a converter will turn a resource into a different type of resource. I go out and I mine ore, and then I convert the ore into ingots, and then I convert the ingots into weapons, and then I sell the weapons. And then the weapons deteriorate over time, and then somebody has to buy a new one. And then traders. I can trade ownership of resources. Hey, do you need this? Do you need that? That kind of stuff. Most of the online games like World of Warcraft, EVE Online, or Star Wars Galaxies, or any of the big ones, they all have an auction house, and the majority of people, make the people with the most money in game make it from the auction house and trading different items. So balancing the economy can be one of the hardest things to deal with as a designer. And they typically, they have ideas and they put the stuff in the game, but then when the alpha and the beta players come in, they observe those. How much money are they making? How much money are they spending? That kind of stuff, and then they tweak things before the final launch of the game. All right, and then resources can be tangible or intangible. A block of iron ore has physical properties, but a token to allow access to something would not require space or take up that kind of stuff. All right, and then they mention here, in a feedback loop, a production mechanism requires some of the resources that the mechanism itself produces. And a good example of this is planetary interaction in EVE Online. And I'll link you guys a video and put it down at the bottom in the material folder this week. But with planetary interaction, you can actually mine planets. But they have different tiers of resources that you can mine. And the tier 1 resources go into making the tier 2, and tier 2 goes into tier 3, and tier 3 goes into tier 5. So there's this giant loop. So basically you've got this giant chain of stuff, and if any one of your planets dies or quits producing, it stops the whole assembly line. All right, moving on. Alright, two production mechanisms that require each other's input as inputs, or outputs as inputs, are mutually dependent. Well, that's kind of self-explanatory. In static equilibrium, because we use that term all the time, the amount of resources produced and consumed remains the same. Well, hence the static. And then in dynamic equilibrium, the amount of resources produced and consumed fluctuates clinically, or cyclically. Wow, I need to go to bed. So your resources can be in a static state or a dynamic state. In static, what's produced and consumed is typically relatively the same. Where in dynamic ones, you have ebbs and flows, high tides and low tides. And where we typically see the dynamic stuff is at the launch of expansion packs. Like right now, Star Wars: The Old Republic just launched a new expansion that allows people to go from level 60 to level 65. Well, for the last year or so, 60 has been the limit. So pretty much everybody had their level 60 gear. Everybody's level 60 gear was all like decorated and the way they wanted it. So the economy was kind of getting stale. But when the new expansion just came out this week, everybody was going from 60 to 65 and getting new armor, and then they had to put augments inside that armor, and then they had to dye that armor. So people like me are making a boatload of augments and dyes and selling them big time right now. And so you see that dynamic. So now everything is selling, but in a couple months, once everybody is level 65, then that'll go down. So right now, resources are being consumed at an astronomical rate, but again, in a couple months, it'll all just kind of like calm down and it'll be back to normal. All right, moving on. Core mechanics. The challenges that the player deals with are all driven by the core mechanics. If my game engine can only produce X amount of this and this and that, then that's what I have to work with. So I have to make challenges based on those mechanics or those properties. So our core mechanics are used to implement those challenges, and they're used to perform tests to see if the challenge has been surmounted, or has the challenge been passed? Is the quest fulfilled? Then there are passive and active challenges. A passive challenge may be getting through a maze. It doesn't require any physical or any mechanic to operate. Where an active challenge may be, a player has to jump between 3 different places and then get on a moving cart and then do something else and then trigger a switch that opens a door, that kind of stuff. All right, and then actions in the core mechanics. The player action or the triggers and the trigger mechanics shouldn't change drastically throughout the game. Once you teach the user or the player how to do different things, you don't want to interrupt that flow. And that's why some of the more, I don't want to say simplest, but some of the best games out there don't really change a whole lot as you progress. Like if you look at Super Mario Brothers, the original, and what a huge selling thing was, once you learn to jump, and I could jump on the enemy, and I could hit the little things, and if I got mushrooms, it would make me grow. That was the whole mechanic. And that was like that through the whole game. And you learned that in the very first level. In Super Meat Boy, which has sold millions of copies, you learn everything in the first level. I learned how to jump. I learned how to stick to the wall. I learned how to jump up a single wall. I learned to avoid the shredders. So some of the most successful games teach you the triggers and the mechanics at the very beginning, and then those triggers and mechanics don't change drastically throughout the rest of the game. Now that works great for single player games, but for online games, players want new challenges. And then that's where you get more complicated actions, and you get into like raiding, like in World of Warcraft or operations in Star Wars: The Old Republic or stuff like that. Each dungeon or each raid group or whatever mechanism whatever you're tackling. So this week we're doing this dungeon, and this week we're doing this dungeon. Well, different dungeons have different mechanics, and this monster will stun everybody, and then he'll do this. Where this monster will, if you hit him, when he goes red, then this happens, and that kind of stuff. So each different dungeon has different monsters that have different actions, and you'll have to work differently with each group. And if you ever want to see a good video of a raid, look for World of Warcraft Leroy Jenkins. Awesome. In a nutshell, these guys are like working on a raid, and a raid is a dungeon that you have to kind of get through. Sometimes they can take hours to do, and they take a lot of planning. Well, everybody's like near the I don't know what stage they're in the dungeon, but they've been doing it for at least a half an hour. And the one guy goes and goes to the bathroom, and then they're all sitting outside this big room waiting, and they're talking about their strategy, what they're going to do. And they're like, hey, make sure that we stay away from these things, and make sure we don't do this and don't do that, because that'll all trigger a whole bunch of stuff to attack us. And then all of a sudden the guy comes back from the bathroom, and he's like, Leroy Jenkins, and he says his name, and he goes flying in the room, and just triggers everything, and the whole party gets killed, and they're all screaming at him, and it's hilarious. It's become such a staple now that in the World of Warcraft trading card game, there's actually a Leroy Jenkins card, and people still use that term when they're talking about gaming. Don't pull a Leroy Jenkins. All right, but I digress. So designing the core mechanics. So keep it simple and elegant. Create generalized systems from patterns. And remember, with Super Mario Brothers and Super Meat Boy and that kind of stuff, try to do all the triggers and the stuff the player needs to learn in the first level or the first two levels. And then after that, you can kind of do variations of that. Like first, okay, I know I need to stay away from the saw. Well, now the saw moves, and now the saw is moving up and down, and now the saw is moving left and right, and now the saw is moving forward and back, and all kinds of weird stuff. So you can make small changes, but the player knows, hey, I need to avoid that. And when you're designing it, you don't need everything perfect on paper. You don't need every frickin' detail. You just need a general outline. And that's where a lot of people go wrong, especially like new indie gamers or new indie game developers. They try to do too much in the design phase. Hey, I want to and get so my design document now is 500 pages, and it's like, what the frick? And it gets all kind of weird. So take a step back and just try to get just the outline. Hey, I want this, 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 and this. And again, don't go into it too much. And then once you have that done, then build a prototype, test it, and then refine it. Okay, all right, hey, this was neat. I like this, but when we actually design it, it doesn't really work for the game. So let's either redesign it or get rid of it. And if you're working in a company and there's other programmers involved, you need to discuss the level of detail that they want to see in your documentation. Again, it all depends on where you work. Some people will want more information, other people will want less information. Some people want more freedom to do what they want to do, so they just want to look at an idea and pop it in their way, as opposed to you telling them specifically what you want them to do. Alright, and then as you're going through the design process, revisit earlier design work on the project to identify entities and mechanics. And then they say, nouns will probably be entities and verbs are going to be mechanics. But you want to keep coming back to your original design document to make sure that the game that you're building, hasn't changed or kind of taken a life of its own. And that's what can happen. Like your design document can say, this is the kind of game I want, and then the game you get can be totally different because you didn't really follow it. You used it as a guide, but then it kind of got off track, and nobody ever put it back on track. Alright, and then more exam questions. Hey, list the entities and resources. Does a noun describe a resource or an entity? If an entity, is the entity a simple entity or a compound entity? Again, in the real game programming world, they don't talk like that. So, moving on. So, when you're doing your game and you're designing things, just remember everything has a relationship with something else. Anytime you introduce money into the economy, different things can happen. Players, you can devalue that money because there might be something not to spend it on, or you may have the players buying the very best gear too early, and then becoming stronger, and then the game seeming too easy, and then forcing players to leave the game, things like that. So everything that you add into the game or take away from the game has a relationship with other events in the game. Alright, think about your resources. And track that stuff, especially like in the alpha and the beta phases. You should be tracking, how many resources are being pulled, how many resources are sitting in players' inventories, how many swords are being made, stuff like that. So you can say, hey, you know what? There's an issue here. We've got 5,000 people that are playing, and we're making 30,000 swords. So that's way too many. So I need to tone down the resources to kind of make that in line with my player population. Alright, so study your entities, analyze the challenges and actions, and really, that's not necessarily family, but more friends. Your family will typically tell you everything you do is great. If I showed my sister some game I designed, she'd be like, oh, it's so great, I'm so proud of you. I mean, it could be the crappiest game in the world. But your friends will typically be a lot more honest with you. And obviously you want to have some focus groups or stuff like that. You want to have a team that kind of maybe comes in and maybe go to Walmart or somewhere and say, hey, can I get you guys and blah to test this out, something like that, and have them test the different elements and then kind of give you some feedback on it. It's a lot easier when you're in school because you can have the class do it. Hey class, I'm going to put my game up on this web player. Can you check it out and tell me if you were okay with this first challenge? What did you like about it? What did you hate about it? Something like that. Remember, feedback is the breakfast of champions. One of the issues with today's games is beta is more a way of getting your game out there and marketing your game. and not really testing your game. We don't really take the input that we get from the beta players and use it to improve the game like we used to. We used to have betas that went for a year or more, and now we're seeing betas that last, a couple months, or even a month or two. There was a game called Pathfinder Online that was in early access, and they went through alpha and beta phases pretty fast. And then they were like, well, we're in a crowd forging phase or whatever that was. And the game was terrible, and they didn't make enough money, and it all folded, and it died. All right, then your book gets all crazy, and we get into random numbers and the Gaussian curve. Did I say that right? Probably not. All right, so in layman's terms, anytime you use a computer to generate a random number, you don't get a random number. If I use the same code and I give it the same inputs every time, say, hey, generate a random number, and I'm just using the same code, it will generate the exact same number every time. So the only way to change that is if I give it a seed. So like I say 9, so whatever his random number is, it might divide by 9 or multiply by 9, or 9 goes into that sequence number. So we call that a seed number. So if the two different programs, if program 1 uses a seed of 2 and program 2 uses a seed of 9, they'll get two different numbers. But if they didn't have a seed, they would generate the exact same number. So there's uniform distribution and then non-uniform distribution. In uniform distribution, the chance of getting any number equals the chance of getting any other numbers. Where in non-uniform distributions, it's going to be a random number, and there's no equal chance of getting a... Wow, I just really tore that all up. You have more of a weight of the player failing than getting it, and that way you keep that item as a unique or a rare. The last thing you want for every player in World of Warcraft to have the Sword of Truth. Alright, so an example of a non-uniform number would be using 3 6-sided dice and then, rolling those. So the values would be between 3 and 18. So 10 and 11 would be a very common roll. But 3 and 18 are very rare rolls. Getting all 3 as a 1 or all 3 as a 6 are very hard to do. Alright, and then you have the Monte Carlo simulation. So basically this just means testing it different times under different conditions to see how it's going to work. And this is typically where we have Q&A departments. And these guys go in and they do it over and over and over again. They'll jump up, they'll jump down, they'll jump sideways, they'll jump left. They'll check the map to make sure they can't fall out. And this is where the players can really come in, and this is where a good alpha testing phase can really help you, because players are looking to break your game. They're looking for ways they can get around different systems and get an advantage over other players. Where being a tester, for a company is actually very boring. They're like, okay, here's this pit. I want you to, jump over it 1,000 times and try to using it different ways. And by the third, fourth time, you're like, oh my gosh, I can't believe I have this job. It's terrible. But where a player will do different things. So a good alpha test where you can actually, as a GM, sit back invisible and kind of watch how players, do this challenge and track the data. You can actually get a much better idea of, is it working or is it not working? So, whoever has the most data is the king, or whoever owns the data is king. So you want to get as much data as possible on your game. What are players enjoying? What are players putting in their inventory? What are players building? What are players spending their money on? What's the average income of a player? How much money have the average player accumulated? All of this stuff will help you in an alpha phase to generate a better launch later on. Alright, so then the summary, blah, 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 blah. Alright, so I'm going to link this video inside your folder, and this will kind of walk you through, just kind of see what planetary interaction is and how it loops, and just the mechanics involved and how they had to have different planets to generate different resources, and then different quantities of the resources, and all the different stuff in the background that went into this mechanic. So that about wraps it up. Remember, if you have any questions, make sure you email me. Other than that, have a great week, folks.